So what is harmonic motion? It's basically a type of motion in which it is symmetrical to a point that is made up of these motions. An example of this can be a grandfather clock or a string on a guitar. Our project relates to harmonic motion because the sunlight remains in a certain motion annually. You can create a trig model based on the points you have used to graph the sunrise and sunset using the points from your city. The effects of this trig equation is that they all have to do with a certain pattern or motion that is consistent with your city, which happen in real-world examples of harmonic motion. The purpose of modeling data was to see a relation between the sunrise and sunset in our graphs, and the model can determine the future outcomes of what harmonic motion may have in real-world events like sunrise and sunsets in other cities.
To find the amplitude of the sunrise data, we did 1/2 of the y maximum minus the y minimum. This left us with a equaling 1.14. By multiplying 2 to the subtraction of the last day maximum and the first day maximum, we found the b, which affects one period of one cycle. This left me with my b, which is 2 pi over 315. To find the c, I used the phase shift, which is c over b. I used the maximum x, which is 15, and equaled it to c over my b. This left me with 2 pi over 21. To find the midpoint, which is d, I did 1/2 of the addition of y maximum and the y minimum. This left me with d equals 5.84. To get my final equation, I substituted all the letters into the equation of cosine.
To find the amplitude, all we did was get the difference between the y maximum and the y minimum and divide it by 2. We ended up with 1.2. In order to find our b, we had to find the difference between our last day max and our first day max and equal it to 2 pi over b. Our answer was pi over 150. To find c, I used the phase shift, which was c over b. I first got the maximum of x, which was 184, and divided it by our b, which was pi over 150. We ended up with 184 pi over 150. To find d, I used the midpoint formula, which was 1/2 y max plus y min. We ended up with d equaling 17.95. My final equation was 1.2 cosine times pi over 150 minus 184 pi over 150 plus 17.95. The only difference with sine is that the a is negative with sine, so it reflects and becomes similar to the cosine equation, and as well as c over b. C over b was modified after the equation was added to the graph in Desmos because of it becoming more accurate to the cosine graph.